Hello everyone, this is the fifth lecture of the data science series. In that lecture, the topic is the model evaluation. In the model evaluation, first topic is how to perform the model evaluation using RPython. Model evaluation is the critical step in the machine learning that assesses a model performance and the reliability. It ensures that the model generalizes well to the unseen data, making it suitable for the practical applications. The evaluation process involves using the matrices and the techniques to measure how well the model predicts outcomes and handles error. There are the few key concepts in the model evaluation. First is the train test slipped. Second is the cross validation. Third is the evaluation, and fourth fitting and underfitting. Fifth is the confusion matrix, and sixth is the residual analysis. So let's try to understand one by one every key concept. First is the train test split. In the train test split, data is typically divided into training and test set. The model is trained on the training set and evaluated on the test set to measure its performance on unseen data. A common split is the 80 to 20 or 70 to 30. Second is the cross validation. Cross validation, such as a k-fold cross validation, further divides the training data into k subsets. The model in the trained on the k1 subsets and validated on the remaining one. This process repeats k times, ensuring robust evaluation across multiple data partitions. The third is the evaluation matrix. In the evaluation matrix, there are the two types: classification models and the regression models. Classification models metrics like accuracy, precision, recalls, F1 score, and the area under the ROC curves. AUC, ROC measure a model classification performance. Precision recall metrics are the crucial for the imbalanced dataset. The second is the regression model. Metrics like means squared error, MSE, means absolute error, MAE, R squared, and the root means squared error, RMSE, quantify the difference between the predicted and the actual value. And the fourth is the overfitting underfitting. Evaluation helps identify overfitting, excellent performance on the training data but poor generalization, or underfitting, poor performance on the both training and the test set. Fifth is the confusion matrix. For the classification models, the confusion matrix provides a summary of the prediction, helping to calculate the metrics like precision and recall. The sixth is the residual analysis. For the regression model, analyzing residual difference between the predicted and the actual value helps evaluate model accuracy and the error pattern. The outcomes of the model evaluation is effective evaluation ensure the model robustness, accuracy, and reliability, enabling informed decision about the deployment or the refinement for the practical application. The second topic is accounting for the unequal error cost using RPython. In the scenario where the different type of classifications error carry unequally cost, you can account for this by the adjusting the model to prioritize the most costly error. Here how? First is the class weight, second is the custom loss function, and the third is the confusion matrix analysis. First is the class weight. Assign weights to the classes in the model that support. Example, random forest classifier, logistic regression in the skitlearn. Use class weight equal to balance or specify custom weight to give more importance to classes with the higher error cost. Second is the custom loss function. For the more control, create a custom loss function that penalizes certain error more heavily. They can be used with the model supporting custom metrics such as the TensorFlow or with the advanced implementation in the skitlearning. Third is the confusion matrix analysis. Use the confusion matrix to identify and adjust for the costly misclassification, ensuring the evaluation matrix align with the business goal. Let's say the example of the both model evaluation and the accounting for the unequal error. These are the example of the model evaluation. First of all, imports the panda as PD from sklearn, and these are the taking input data, and let's see the output. Accuracy, these are the output of this code.